All right, fingers crossed this one's a little bit clearer. I'm doing the best I can. Okay, the next thing we need to look at, matrices can represent practical situations, all right? So if we're looking at a round robin, if we're looking at a scorecard, if we're looking at things the way are connected, and if there are paths to and from things, we can draw that up in a matrix. So, pretending this is a town, A, B, and C, all right? You can go from C, you can go to B, B can go back to C, and A can go to C. All right, so we've got town A, town C, and town B. We can write this up in a 3 by 3 matrix. Okay, so down the side we have A, B, C, A, B, C across the top. Okay, and this is going to record how many ways we can get from one to the other. So let's look at town A, and we always read these across to up. So we will go from our row to our column. A to A you can't go, B to B you can't go, and C to C you can't go. So we're going to put zeros on the diagonal, okay, because you can't get to the town from the town. Looking here, how many ways can I get from A to B? There are no connections, all right, so I can't go from A to B, which also means that I can't go from B to A. So they are corresponding elements. Because I can't go from A to B, there's no path, which means I can't go back in reverse. Alright, so we've just filled in 2. You will be filling in 2 at a time. How many ways can I go from A to C? There is one path there, and there is one path there. There are 2 ways I can go from A to C, 2 roads, which also means there are 2 roads from C to A. Looking here, how many ways can I go from B to C? Surprise, surprise. There is 2 there, and there is another 2 there. Now, to make sure your matrix is correct, if we had an imaginary line down here, you will see that it's actually symmetrical. If this was folded in half, it would be the same thing. Adding to a little bit of a problem, if we were looking here, all right, and we have a loop that looked like that, and there was a road from A to A, all right, we could go back and we could fix this, and a loop represents one path to get from A to A, all right, and that is a loop. That is called a loop, and these are just called paths, all right. What other scenario we could do? If we had a really quick round robin that we needed to write up, we have team A versus B, and A wins. B versus C, C wins. A versus C, A wins. And who's B got a verse again? B's played A. Alright, they've all won. Okay. So, if we're looking here, round robin, here are our winners. A, C, and A. Okay? A, B, C comes down the side. A, B, C goes across the top. A didn't play itself. Put a 0 in. B also didn't play itself, so put a 0 in there. And C also didn't play itself, so put a 0 in there. Now when we're looking at A versus B, A won, so they get a 1. B didn't win, so they get a 0. So when B plays A 0 goes in there. B versus C, we go to B row, C column, C 1. Alright, so they get a 0, but C gets a 1 because we have C with B gets a 1. And A versus C, A 1, so A goes to C, A 1, which means C lost down there. So remember, we always need to read it A to B, A to C, B to A, B to B, B to C. It's always row, then column up and down. Okay? And that's basically all you need for that one.